Yes, good afternoon, everybody. Welcome to this session of sustainable construction methods. Today, we'll be seeing this topic what is planning approach as it is related to modular coordination. As we know, planning is the first and foremost step in achieving any project. So, how should we approach that? How should the planning start? We'll be seeing that today. Let us see here. You can see here what is this phase planning. As I had told you what is N and M, how it is denoted. As we had seen, M is denoted with a 100 mm a unit. So let us see what is phase plan. You can see a small plan here. You can see rooms and doors have been placed here. As I had told you, we plan everything in a grid. Everything is planned in a grid. Even those grids and the lines have been specified. What are the size of those lines and the grids? Everything has been specified perfectly. So let us see what is phase planning. It is used to position components of construction in relation to the grid. So basically what we want to do is whatever units we want to have in our plan, we set that in a particular grid. We directly don't uh, plan it without the grid basically, but we want everything to plan in a grid section because it will be easy in further when while we approach towards the design process also, there it will become very easy. So it is represented by a pair of parallel lines. As you had seen here, this is the pair of parallel lines are everywhere, you can see here. And these parallel lines have been joined with one another to make a one particular unit. The component is placed with the faces on the lines. With the faces on the lines, the component are placed like these walls come on these lines. You can see here these lines have been marked as if walls are here, and these this is a door opening here, door opening, and this is a door, this is a wall here. So everything has been marked on the grid lines. The distance between the set of parallel lines is always modular. As I told you, the distance between them is similar. This is similar, it is not modular. If by chance we need some partition here, then we come up with some other grid lines which is non-modular. So this is a specific size of grids. It has been mentioned earlier also, like in the horizontal direction it is 3m, that is 300 mm. In the vertical direction it is 100 mm. So this is how this grids have been set. So these are always modular here. Let us see here what is axial planning. It normally determines the position of major components, example columns, cross walls. So axial planning here, you can see columns have been placed here at the corner. They have been marked with, you can see here, the columns have been marked here at the corner. Here there is a column placed at this place, and wherever columns are needed, they have been marked. If we don't need a column here in between, so it has not been marked here, and a straight line, that is the walls, have been marked here. So basically what we want to do is we want to mark everything along the grid only. We don't want to mark anything away from the grid, out of the grid, because these grids have been made to make the work easier. You can understand this at a later stage when we come across the design part. There you will find it very easier because of this grid section. The design can be made very easy. The grid lines in this plan will run along the center lines of the component. So grid lines run along the center line of the component. You can see here, this is the grid line. It is running along the center line of the component. You can see here center line, and this has been marked for columns and cross wall. For columns, because for columns we want to see what is center to center. So this grid here has been marked at the center. You can see here all these grids. You can see these lines with a circle here. These have been marked at the center. So this is called as axial planning. In the previous slide you had seen the grids were not marked at the center, but there were two lines, parallel two lines, and everything was placed onto those lines only. Here, because this is the column marking or cross walls marking, so everything center to center distance we need. So here these type of planning is very essential and helpful at this stage. The grid lines in this plan will run along the center lines of the components. The distance between the grid lines is always modular. As I had told you, basically we are going only for modular sections. We don't go for non-modular section at this place. So this is modular only, but if you want to come up with some other partition here, then we have to come up with some other setup. Let us see combination of phase and axial planning. You can see both of them are here. In this planning process, it is easier to begin with a modular grid and determine the positions of the major elements using the axial plan. You can see a center line. First we determine whatever units we want, whatever elements we want using the axial planning. We use the axial planning and we determine the elements whatever needed. So basically here center to center can be got very easily with these grid lines here. Then what we do, the phase planning will then be introduced for the positioning and sizing of various components and also to design the joints. So here after taking the axial planning, which takes only center to center, then this phase planning has come up. This has been inserted here, and by this we can see what the elements of what size are coming in between these parallel lines. So here this is how this is done. You can see center to center marking is also there in this planning. This is the combination of both of them. You have both of them simultaneously. You have center to center markings as well as the phase planning also, where the grid has been marked according to the elements what we need. So this are both of them are together here. You can see here horizontal planning. Now let us see what is horizontal planning. You can see here this is in horizontal planning. You have phase planning as well as axial planning. As I had told you, whatever units which we need as per our need for horizontal in a horizontal direction. Here the same way, this is the phase planning. You can see here the columns have been marked here horizontal direction. This direction you can see here, this NM you can see with the arrows marked here. This is the distance it is being showing here. The same way for axial planning, as I told you, in axial planning we'll be taking center to center line. So that is what the dimensions have been shown here with this arrows you can see here. So this is horizontal planning. This is also essential. We need vertical planning as well as horizontal planning, so that the elements have been marked properly. What happens if we do this planning properly, then the execution on the field can be done without a minute mistake also. Or else what happens if these dimensions are not marked properly, then this has been seen on field, while executing there has been slight differences and slight deviations. Because of that, the deviations have taken place and the whole aesthetic view has been lost because of these small problems. So this is very important. If the planning is good, the execution can be done very properly. You can see our vertical planning is also there. As we had seen the horizontal planning, the same way vertical planning is also important. Preferred dimensions vertical planning is 1m, that is 100 mm, 0.5 m as second preference. If you need to some other minute, you want to decrease the size, then you have 0.5 m also. Windows multiples of 1 m, multiples whatever it is into 100 mm. Doors multiples of 1 m. So you can see here, just see this figure here, vertical controlling dimensions, floor to floor height. You can see here floor to floor height is also there, floor to ceiling height is also there, and you have floor zone and roof zone. Floor to ceiling height, you can see here floor to ceiling height. You can see here from this part to this part, this is floor to ceiling. This is where your ceiling is touching here. But floor to floor height, you can see here, from here floor to floor height, from here from this part to this part. Floor to floor height is from this part, from this arrow to this arrow. This is the floor zone. Basically we had this is the false ceiling that has been created here. That is why floor to ceiling height is what exactly we'll be achieving. That has been marked here, like whatever we want to maintain the dimensions here. So that is marked separately. Floor to floor height is marked separately. You can see here ceiling height from this part to this part. Window height is also here. Ceiling height is also given here separately. Window head height. Window head height. What will be the height of the window here? Even that has been marked. Sill height, from where we'll have to take the bottom of the window. Floor zone, you can see. So everything is marked. Everything is marked minutely here, so that there shouldn't be any fault while executing. Intermediate controlling, you can see here, just intermediate controlling dimensions. Door head height is also there, window head height is also there, window sill height. As I told you here, window head height, sill height and door head height, everything has been marked properly. Just see here, you can see here, see this room height, non-modular room height is that. This is the ceiling, this is the floor. After that the ceiling will come. So we want to see what exactly from where what is coming. Story height, from one part to the floor. one part of the floor to other part of the floor. That is the story height. Room height is, you can see a room height will be seen from the bottom to the height of the ceiling. This is the room height. You can see here door height has been marked separately here, window height has been fixed properly here, window height. This is the sill height. Till here the sill will become, and there the window will be fixed from here to here. So everything will be marked with every minute dimensions, so while executing there shouldn't be any problem. Door, window height, even this horizontal size has also been marked here. Wall will come till here, this will be the, this is the grid, and here the door or the window width will be like this. So everything with each and every small minute dimensions will also be marked here. You can see here vertical coordination is also seen here. For example, they have been, we are showing here this. You can see here this is the floor to floor height. These are the walls which have been casted here. You can see everything has been marked. Let us see further boundary planning. So this is the boundary planning is also being given here. Horizontal coordination is also being marked here, as well as axial planning. Axial planning, as I told you, center to center is there. And horizontal planning, we see what is this horizontal distance. In vertical coordination, we see what is this vertical height. So everything needs to be marked separately. Modular wall zone inside of a modular line, you can see here where will the wall come, exactly where will the wall come, where we'll have to fix whenever needed. In, because in modular construction what happens is we fix up some boards, v boards also, and then we pour some concrete so that it gets hardened there only. So it is not like these walls, but conventional walls where we come up with red bricks or some other cement bricks, other concrete bricks, or rather you can say, but this is different with the concrete wall. So you can see a wall zone, outer face, and modular line, everything has been marked separately. This is the, this is needed separately. We want to mark everything very separately, so that you can see your center line has been marked here. So even this is not missed out. Axial planning, boundary planning, everything is marked here separately. You can just see how the windows and the doors have been fixed properly. Sill height is given here. From here the window will be fixed. Then the door set has been given here, where the door set will become. Room height is, that is you can see here it is given as n is equal to 2 meters. Till here it has been given. Then floor height is here, false ceiling will come up here. So everything whatever is there, that will be perfectly marked here into the planning section only, so that while executing there shouldn't be any problem here. Now let us see position of functional elements like slab, walls, and staircase. How do we position them? This is very much important here. Let us see there. Floor slabs, depth floor slabs. You can see a depth will be in sub-modular increments of 0.5 m, 50 mm, and 0.2 m. As I told you, everything is being marked with this m only, units of m. So depending on whatever our need is, the depth of the floor, we'll be just marking it here, and it will, this grid will be formed here. You can see top of floor zone, floor finish is there, slab is being given there, service space, false ceiling, everything has been marked. Precast slabs are available in width of 6 m, that is 600 mm. 600 mm. M, as I had told you, we denoted for 100 mm. 6m means that is 600 mm. Length can be varied according to the requirements. Length can change according to the requirements, but the depth is 600 mm. These dimension fits the structural grid, thus there is no wastage. So directly it fits the structural grid, so there is no chance of wastage here. The floor zone is the space allocated for the floor assembly. It extends from the reference plane of the ceiling to that of the finished floor above it. You can see here from this part to the, you can see here, you can top of floor zone, this is the top of floor zone is given here. This is the space where everything can be allocated here, and the slab comes over here, and what is floor finish load comes over there. Above the slab, you can see here, this is the floor finish load. What we put is, when we go for flooring, whatever flooring we type of flooring whatever we are using, either it is marble or granite or tile flooring, whatever it is, we have to put some floor finish load here. Then above that, these tiles or the flooring comes up. So even that, this is the top of the floor zone. From there to here, this is the bottom of the floor zone. This is how the floor zone will be indicated here. It extends from reference plane of the ceiling to the finished floor above it. Let us see here. Walls. In walls, the length is determined by choosing planning grid. The length is determined depending on the planning grid, what type of walls we would need, what size of walls we need, what thickness. Sub-modular increments of 0.5 mm and 0.25 mm are recommended for thickness of walls. Depending on our thickness of walls, what type, either we want 4.5 4 feet 5 inches wall, or 9 inches no, 4.5 inches wall, or 9 inches wall. Whatever we want, we can just mark it here. Sometimes we even have the 6-inch wall, so we can mark whatever need. As per our need, we can mark it here into the grid. Allowance must be given for thickness of finishes to be used. For finishes also, even there, that allowance also should be given here. So whatever our need is, that can be marked here itself. Let us see the bricks. Now how the bricks you can see, this has been seen as the height, this is the length, and this is the breadth. What type of bricks we are using? You can see here everything else. This is what are the dimensions. Length is 200, everything is in mm, breadth is 100 mm, height is 100 or 50, whatever we need. So in actual nominal, this is the nominal and this is actual. 190, 90, height is 90 or 40. So non-modular, conventional, whenever we go for conventional bricks, this is for modular bricks, and this is non-modular, that is conventional bricks. The length is 240, it is a little bit big, and the breadth is 120, and the height is 80 or 40. You can see here in this modular, the height is very easier. It is either 100 or 50. Here you have the height is 80 or 40 here. So this is the height difference in height here in modular. Even here you can see the length is 119 modular, and in conventional it is 230. Breadth is 90, here it is 110, but the height is 90 and 40, here the height is 70 and 35. So this is a small difference in modular and conventional. You can see here, this is how the bricks can be placed here depending on whatever need, where we want to go. Bond dimensions, brick modulus. So all this can be, this is a wall, how we want to place our bricks, everything can be seen in these planning only. Everything can be, we can even see the quantity required for our construction. Everything can be got here only. You can see this is how the bricks have been placed: half brick, 1.5 brick. So everything can be seen here only, how it can be marked, and even the sizes have been given. So it will be very easy for the artisans to work on the field. Execution will be very easy with these small planning approaches. If this is not done, then what happens? There is lot of wastage. First they build it, then they see it is not correct, they again remove it, they again remove that element, again they cast it. So everything, all these things lead to wastage. Even that is reduced here because of better planning. We can see a staircase here. In staircases also on plan, the width of coordinating space accommodates the two flights and possible space in between them. You can see here riser dimensions: 150 if you need, 165 and 175. Floor to floor height if it is 2800 mm, floor to floor height if it is 3150, if it is floor to floor height it is 3000, 3300, 3500. How many risers, what is the size of the risers? You have 16 risers. For 2800 mm floor height, you'll have 16 risers. For 3150 height, you'll have 18 risers. For these you'll have 20 risers. For this height you'll have 22, and for this height you'll have 24 risers. So everything has been marked very specifically. You can see the riser height and the number of risers, everything has been given here. So it is very easy. If all this is marked properly, then there won't be any deviation. On plan, the width of coordinating spaces accommodates the two flights and possible space in between. Flight and landing, both the dimensions are modulars. You can see size of thread is also given, that is 250 mm here. You can just see here in section, the stairs will be located in between the floor coordinating lines. This is how you place it here. The dimension of the total width, the length of the flight, and the width of landing must be in multiples of 1 m. Even what is the landing size, even that is in the multiples of 1 m or and 0.5 m. You can just see here how properly everything has been marked, so you won't have any problem. Then when you give this type of plans to the artisans, they can mark it very easily. There won't be problems while casting staircase. Normally it has been seen the deviations or the problems come up with staircase only if they are not marked properly. If you give these dimensions, the height you have given, where this landing will come, and how many risers will come, uh, the total amount of steps coming, everything can be calculated very easily. Now let us see standardization of components. This is also a topic. Let us see it in brief. The preferred dimensions of precast elements according to NBC shall be as follows. Flooring and roofing scheme, precast slabs or other precast structural flooring units. Length, nominal length shall be in multiples of 1 m. The length of the flooring scheme should be 1 m. Width, nominal width shall be multiples of 0.5. Overall thickness shall be in multiples of 0.1 m. This is for flooring standardization. All these components have been standardized. They have been specific dimensions have been given for these elements. Let us see for beams, the length, width and the overall depth, everything has been marked with multiples of 1 m or 0.1 m, and the depth also at 0.1 m. So everything has been standardized. We can't give anything other than that. Columns, you can see height of columns for industrial and other buildings is 1 m, and lateral, that is multiples of 1 m, and lateral dimensions, overall lateral dimension or diameter of column shall be in multiples of 0.1 m. You can see this is the columns. Walls thickness, the nominal thickness of walls should be in multiples of 0.1 m. As I told you, everything is in multiples of m. Staircase width, nominal width shall be in multiples of 1 m. Lintels, even the lintel size have been given here. You can see nominal length shall be in multiples of 1 m, width should be in multiples of 0.1 m, and depth should be 0.1 m. So everything has been marked here. Everything is specific. Each and every inch can be saved here. Each and every rather, you can say, can be saved here if this proper planning has been given. Sunshades or chhajja, you can say, nominal length shall be in multiples of 1 m. See here. Example. Just see it here. Just see here how the bedroom. You can see here the bedroom has been marked here. This size of the this you can see 322 m. That is 2200 mm. This is from here to here. This is 6 m. That is 600 mm. This is 6 m. 600 mm. Then you can see a 3 m. That is bedroom. You can see a 300 mm. So 8 m. You can see here. So everything has been marked here so specifically. You can just see here. You can see your plan here. 8 m, 18 meters. 18, that is not meters. Don't get confused here. M means 100 mm. So this is 800 mm. This is 18 18 m, 12 m. Everything you can see. Just see here. Courtyard. Everything has been marked here specifically. Specifically, everything has been marked here. With the section has been given here. How, what will it be like? So you can just see here everything, exact spaces have been marked here. What shall be the size? This is the elevation, you can see. So in elevation part, every inch plays a very important role in proper planning. If that is not marked properly, then your whole elevation can go wrong. There might be deviations and the look might not get as you have expected. So this is here, everything has been marked here. So this has to be followed very properly, as you can see here. Let us conclude it here. Modular coordination requires considerable effort. See, lot of effort is needed here because each and every is trying to be saved and everything has to be got onto the plan. A lot of efforts have to be put here to get everything on paper. And discipline and the process may not be pleasant, at least initially. Initially it won't look pleasant because lot of work is needed here. Lot of rough drafts and final drafts are needed here. Finally, however, in the long term it is likely to pay off when the tool is understood and used effectively, more so if implemented throughout the industry. If everybody tries to implement this, as of now what happens is we try to save whatever time we want at this point, but further later on, if whatever what we have planned, if that goes wrong while executing, then there will be loss of money as well as loss of time, and there will be wastage also. So what we feel is if proper coordination is done and proper planning is done, all can be achieved very in a very short time, and lot of wastage can be reduced as well as lot of money can be reduced here with proper planning. Though it requires lot of time and uh, keen design, but still it pays off finally. Thank you. Thanks a lot for this session. Let us see in the next session whatever topics will be covering here. I request all of you all to please go to this video and please comment in the comment section. Thanks a lot. Thank you.